you can hear the sound, then it's automatically added. Okay, if not, then okay, because the screen being closed by this PowerPoint. All right, so now the flow rate of water is 545.41. Now the question asks you to find we go to the question, uh, the amount of water required for cooling process. Okay, so if you do the reduction, there will be a reduction of water flow rate. Okay, initially is 545.41, okay, mole per second. So after the reduction, for sure that value will reduce. So you are required to calculate the value. Okay, so now back to here. So considering for this example, considering 15% reduction, so the reduction is to the inlet flow rate, to the inlet flow rate. So it's 50 lah, to the 50. So 15% from the reduction of the 50, it will be what? 42. 42.785 mole per second. Okay, by assuming, because already mentioned in question, all the operating order is the same, so your Q is still the same. The Q release is the same. This means that negative 1028.334. Okay, so now from this one, we need to find the new flow rate of the water. Okay, so the new flow rate of the water, referring to the table earlier, N2, the new flow rate, because the previous one N1, N2, H1 1.885. That one maintain, no need to do any other calculation. Okay. Wait, that one is 0 N2, H2, wait, kat mana ni, kejap saya nak tengok ni. My H3 is what? 1. Okay, sorry. Q release is the same, so we have to consider now, because Q release is the same, so we have to consider on the cyclopentane, the cyclopentane stream. Okay, so the cyclopentane stream, the flow rate of your, wait, I go back to the question. This also make me confused. Okay, your cyclopentane, estimate the amount of water leakage. Okay, because now your vapor is already been reduced, the flow rate of the vapor is already been reduced, so the percentage of condense is also different. Okay, so percentage of condense is also different. So now I think that the statement here, this statement here, this one. Okay, if you read it is quite confusing. So that's why I always advise to all of you, if you have any uncertainty with the question, please ask the lecturer. Okay, so this one. Cyclopentane vapor production. So that word actually referring to we will have a different value of cyclopentane out there. Okay, so here, if I put here this and 2, this is the flow rate of the cyclopentane vapor out of the system. And then cyclopentane earlier, what is the flow rate? Earlier is cyclopentane vapor is, I can see from the table, 20. Okay, previously this is 20. This one is 20 previously, 20.334. 134. Okay, so now with that reduction, affect the vapor in the product. Okay, but your enthalpy is the same. Okay, and then one more is minus the new value of the inlet, 42.785 with the enthalpy 31.35. Okay, so this one is actually N2 is the vapor flow rate, 42 is the new flow rate. Okay, so cyclopentane liquid is 0 because we have no the enthalpy is 0, right? Yeah, this one 0. Okay, so we only consider this for the cyclopentane. Okay, since it's the same, the operating is the same, so we assume the Q is the same. Okay, but now the flow rate is different. So this is the new flow rate after the reduction, and this should be the new flow rate of the vapor in the outlet. Okay, for sure the liquid also will be different, the liquid flow rate of the cyclopentane. So if you do that, you got N2 of 11.464. Okay, mole per second. The new flow rate of the cyclopentane vapor in the outlet. Okay, so to find the percentage converted, the new percentage of converted cyclopentane vapor to liquid as required here. Okay, so that's why we need to assume that. Okay, we need to assume that. And then the percentage, new percentage is the inlet 42, right? 42,785 minus the one coming out here, 1. No need to calculate the liquid flow rate of the cyclopentane. If you want to calculate, then you can do that, but it's not required because you are required to calculate the estimate the water. Tapi dia kata tanya kan, estimate the water. Estimate the amount of water required for cooling process. Okay, let me check. There is a confusion in the question. All right. So this one, let me check. 73.1. So by reducing the amount, the feed flow rate of the cyclopentane, you should be able to have a higher conversion of the cyclopentane. Okay, wait, I go to the question because the question asks us to estimate the amount of water required for cooling process. Okay, so that is actually your answer here. Here, N1. Okay, so the instruction is quite, again, as I mentioned, it's quite general. So you can do just a normal solution, but please bear in mind on the additional information required from the question. Okay, so this one is a 20 marks question. So I noticed that the mistake made by student is here. Again, as I mentioned here, you have the cyclopentane liquid of different stream. Okay, but if you solve them at energy balance, still okay because you refer to the inlet outlet, still okay. But the drawing concept is wrong. Okay. Any question for this one? This is question 1, I guess. Question 1. Okay, maybe the confusion is here, around here, because you see, decide one value between 10 to 20%, 10 to 20% reduction of cyclopentane vapor production. It should not be vapor production because your production is supposed to be liquid production. Okay, but production here I mean in the product lah, in the product. Okay, so you can just ask me if you have any confusion. question with the, this is the test. Again, with your assignment 1. So if you have any question, just PM me. Now I want to go to the rubric. Okay, so this rubric, this is actually the second question of that MTA, the second question. So for your assignment 1, last question, question number 5, will be, I will give you marks according to the rubric. So rubric is actually, we have a topic. Okay, this is general topic. Your the one I give to you, assignment 1, you are required to prepare question, and then you are required to prepare the solution. Okay, so the topic may be, how complex is your question, because you are required to do multiple, right? Multiple. So we will see how multiple is your process. If you just give one, simple one, so it's totally not in the range of the question. So the topic may be two units of operation is shown. Okay, so if I can just shortly discuss on this rubric. So normally we have a scale here, normally from 1 to 5. So I will only talk about 1 because 1 mark ni normally no, it's always no here, no. Okay, all right. And then for the assumption, okay, so some assumption, normally we will give you 5. Okay, wait. You have full mark here. Okay, so let's say that question is, if we refer to the first question, 20 mark. So normally this one may be, I can say this is 10 maybe, this is 5, this is 2, this is 3. So total will be 20. So that, okay, so where we put your mark here, this column. Okay, so this one, let's say you got 5. 5 over 5 times 2. So it's only 2. But if you get here 5 over 5 times 10 is 10. But if you got 2 over 5 here, it will affect your whole value, your whole marks. Okay, so you should focus on the, the critical, critical part of the question. Okay, for our assignment is on the question and also on the solution. So you should show a detailed solution, and your question also must not copy from anywhere lah. Okay, your own, it's your own. All right, so I'm referring to 5 scale. So for example, calculation of enthalpy, let's say it should have what, 6 enthalpy to be calculated. So all 6 enthalpies are shown. Calculation of all 6 enthalpy are shown. So you got 5 over 5 here. Okay, shown. Okay, not only shown, and correct. So it should a correct value. It should be a correct value lah. Then only you got 5 over 5. So 4 maybe all 6 enthalpy are shown. All calculation of 6 enthalpies are shown, but 2 of them are wrong. Maybe that's a sample of the rubric. So the calculation of the cost. Okay, so the calculation of the cost. So if you are able to get the correct cost, so you should get there 4 over 4, 5 over 5. If not, if no, normally 1, normally no lah, because student always give something. But it's normally it's around 2 to 4. Not many are able to get 5. Okay. So originality is very subjective actually. Tapi originality, normally we go to the fundamental, whether you show step by step. We can see if one copying the other, you can see from the solution actually. Okay, some I would say, because when they're copying, the final value is the same. The step is also the same, but there sometimes there will be, you know, some error somewhere, is or not a complete. Okay, so that I think that is the one who copy lah. Okay, those getting the correct value is the one who give the solution to the rest lah. Okay, so normally there is a pattern lah, a pattern of solution. You know, maybe 6 to 5 patterns of solution again from the discussion lah, although you are not required, not allowed to discuss actually. Okay, but for this assignment, okay to discuss. Okay to discuss lah for me. But for MTA and final assessment, you should not do that. Okay, again, you should be honest to yourself. Okay, honesty is very important for me lah. So because I, you know, other lecturer, they do it synchronized exam. So you are required to on the camera. You are in front of the camera for 2 hours and you answer. But for me, I believe in you know, honesty. If you're honest, then you should get it right. If you are not honest, then you know, something wrong somewhere lah. Okay, so just be honest with me. All right. So I think that's all for today. Any questions? No question, Kasha. So you get all the you know, the information. Rubric kind of question is actually high level thinking, high order thinking. We are required to prepare a question of that kind. Okay, high order thinking. So that is the only question that I am thinking of lah. That's why the question 5 is given to you. Okay, so again, question 5, as I mentioned, if you just, you know, give a simple multiple process, you know, sometimes they put, it must be logic. Okay, again, it must be logic. You know, let's say you have a condenser. After the condenser, you may have a distillation column. Okay, so if I refer to that condenser distillation column, it is not a synchronized process. Okay, so you have to consider that in your question, because you know, condenser is just to convert. Okay, let's see the previous example, the cyclopentane. Condenser is just to convert the phase. And then after that, you need to do distillation column. You have to have distillation column because you want to separate the cyclopentane liquid and the cyclopentane vapor. Do you think it is worth to apply distillation column? So you have to consider that in constructing your question. Okay, so that's why it's under high order thinking question lah. So you have to think of that logic process or that, not to be complex. Okay, not to be complex. Okay, so that's all for today. I'm rushing to my daughter's hostel to take her. Okay, so any question?
Madam.
Yes.
Doctor, can I see the slide number 4?
Slide number 4?
I didn't sempat.
You want to snap?
Yes.
Can. Okay, any more?
Okay, thank you, Doctor.
Okay, sama-sama. Any other questions? If no question, then we stop here. Normally, actually, for your information, those joining my class, normally during assignment week, I have no class with them. Okay, it's just this week. I do not remember this is actually an assignment week, so that's why I'm happy to have a lecture with all of you to discuss on the example of the question. Okay, so any other questions? So your assignment will be what? The submission is next week, no, Sunday, right? Before the test week. Okay, so you have test week, week 7 and 8, right? Yes. Imran?
Sunday bila?
Sunday after Hari Raya.
Oh, okay, doktor.
I put that in the assignment kan, the due date is 16 16 ke? 16 after Hari Raya. I give you more than a week lah, more than a week because you know considering Hari Raya, so you have 2 days of holiday lah to celebrate. After that, work out for your assignment back. Okay, so we will meet again for lecture because week 7 and 8 next week is semester break for Hari Raya. After that is week 7 and then week 8. After week 8 there is another break, I think a week. So we will see another 4 weeks to cover the syllabus of reactive. So 4 weeks, 4 weeks. Okay, we have no class for 4 weeks. And then you should be ready for your test lah, test 1. Okay, it should be, the test is 24 hours, 24 hours test. So I guess 2 questions, maybe 2 questions covering chapter 7 and 8. Okay. Alright, so thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Selamat Hari Raya.
Selamat Hari Raya, Doktor.
Selamat Hari Raya, Doktor.
Selamat Hari Raya.